At 0 seconds, she is at 2 feet. 0.8 seconds later, she's at 6 feet, making one full cycle 1.6 seconds.
At 0 seconds, she was 2 feet off the ground. At 0.8 seconds, she was 6 feet. And at 1.6 seconds, she was back at 2 feet. This is our dotted line. So now for cycle 2. At 2.4 seconds, she was at 6 feet. And at 3.2 seconds, she was at 2 feet. Okay, so our dotted line from our graph was at 4. And then our amplitude, as you can see, would be 2. And to get the number of cycles, we would do 2 pi over 1.6, because from a low point to another low point would be 1.6. And this would give you 5 pi over 4. And since it's inverse, we would put a minus.
So students, our first question is, how high was I, Kathy Lara, at 2 seconds? So in our graph, 2 seconds will be like right around here. And as we d up and to the side, we end up at 4. So to check if that's right, we plug in 2 into our equation. Just plug it in your graph. 4 minus 2 cosine. Make sure you have the parentheses right. And then you just plug in enter. You get 4. Astonishing.
So our second question was, how high will she be at 10 seconds? So you start out with the equation, h equals 4 minus 2 cosine 5 pi over 4 and in parentheses t. So then at 10 seconds, and then that's t, so we're going to plug in 10 for t. So then we start the whole equation all over again. Then 4 minus 2 cosine 5 pi over 4, and then you plug in 10, and then you just plug that into your calculator. Make sure that's in radian mode, and you put 4 minus 2 cosine parentheses 5 pi over 4, and then you plug in 10, and then you get 4. Equals 4.
Question number 3. What are the first 2 positive times when the height is at 3 feet? So first we're going to start with our equation. H equals 4 minus 2 cosine 5 pi over 4t, where t equals time and h equals height. We're given 3 feet in the equation, so we're going to set the whole equation to 3. So 3 equals 4 minus 2 cosine 5 pi over 4t. Now we're going to solve it algebraically. First, we're going to subtract by 4 both sides. We get negative 1 equals negative 2 cosine 5 pi over 4t. Now we're going to divide both sides by negative 2. So we get 1/2 equals cosine 5 pi over 4t. Now we're going to take the inverse cosine of both sides. Calculator. 1.04. We need to do it right here, right now. So we're going to find the general solution right here, right now. Okay, so we're going to do plus or minus 1.04 plus 2 pi n equals, this side the cosines cancel out, so we're left with 5 pi over 4t. Okay, now we're going to multiply by the reciprocal, so it's 4 over 5 pi. Both sides go over here, 4 over 5 pi. So now we're going to use the distributive property. We're going to distribute here and here. So, we carry down the plus or minus. We know that 4 divided by 5 times 1.04. We get 2.61. And then we know that the pi's cancel out, so we end up with 4 times 2 is 8 divided by 5. 8 divided by 5, get 1.6. We carry the 1. There. Okay. That equals t because these cancel out. So we're left with t. And now, cover general solution. Now we found out that our general solution is t equals plus or minus 2.61 plus 1.6n. Now we're going to find the first two positive terms. So we're going to plug this into our calculator. 2.61 plus 1.6 times 0. And we get 2.61. So that's our first positive value. Now we're going to go to the second positive value. We're going to try negative 2.61 plus 1.6 times 1. And we get a negative 1.01. So we know we can't use the negative one of that. So we're going to try positive 2.61 plus 1.6 times 1. And we get a 4.21. So that is our next positive value. In conclusion, sinusoidal functions are used to measure oscillations, to manipulate objects to our own benefit. Some sinusoidal function applications to the real world are waves, sound waves, balancing tires, buoys, and many more. Thank you for watching. Have a great day.